Okay, we're at week 4, and this is set 1, Swyk 1, talking about exponential models. Okay, so let's see if I move this over here. Oops, too far. So the equation we have here is a new one. This is something different. You haven't seen this one. Y equals AB to the X. So it's not like a quadratic or anything like that. This has a fixed base but a variable exponent. So it's something completely new and different. It doesn't fit what we've done before. So there's two parts. You can see that there's a number times a number that's being raised to the variable power. Now, those parentheses sometimes are used to separate, so you understand that the x is only being applied to the power of the b, what we call the growth factor. Now, the growth factor could take on values, definitely always going to take on positive numbers, not going to deal with negative growth factors. But if the value was larger than 1, then we have something called exponential growth. This is what you would want your money to do. Or if you bought an investment of some other sort, you would want the value to go up. A lot of times populations can grow or decline, but in this case, if they were growing, it would look something like this. Now, if the b value is less than 1, now if the growth factor happens to be smaller than 1, so we're talking a decimal, a fraction, 0.5, 0.2, 0.17, 0.73, something like that, then we get into something called exponential decay. Exponential decay is what you don't want your money to do. You'll often see value of cars or things like that will decay in value. Some populations will decay. It is exactly what you want. A bacteria or some kind of deadly disease, those are the things you do want to look like that. You want them to go down in their amount year after year, day after day, or week after week. Now, an exponential function has a value out here which I have labeled A, and that is that in a story problem that'll be your starting point. So let's say you start with $2,000 that you're going to put into a savings account, or the population of bears is 4,000 in a particular state or whatever. So it's the amount of something that you start with. On a graph, it can be noted as the Y-intercept. So that starting amount, that's your A value right there, is a lot of times the reason we call it the starting amount is because in a story problem, we start at time 0. So we have a clock, a definite starting time, and so we're typically using lots of values in quadrant 1 with story problems. Now what's interesting is as you look at this graph, you can see as you go to the left a long way that it's getting closer to the x-axis. If you can imagine, if you stand close to a wall and you take a step forward, cutting the distance in half every single time, always moving forward, but you're always cutting the distance only in half, the reality is you will never reach the wall. Now you'll be awfully close, but you will never actually reach that wall. So that's something that it's kind of hard to understand until you think through it. But the line I've drawn here at the x-axis, I put a dotted line on it, and we do that because we have this really cool name which has a lot of awesome jokes that go with it, the asymptote. So the function is getting closer and closer to that line on this side. Now, as you can see with the decay function, it would be closer and closer on the right side to that asymptote. It's a line that it never crosses, and it gets closer and closer and closer to. So in this particular situation, we have a y value or a growth factor of 0.68. That is exponential decay because the value is getting lower every time. We're starting with 5. That is your y-intercept, 5. Now, It just says type an integer. It doesn't say type a coordinate, so make sure you understand you don't need to write 0, 5. It's just 5. Okay, question 2. Without graphing, determine whether the function represents exponential growth or decay, then find the y-intercept. Okay, well, since 3 is bigger than 1, we know it's growth, and the y-intercept is 4. Question 3. Now, there's a little bit of a trick to this one. We talked in previous chapters about how when you raise something to the negative first exponent, right, anything to the negative first causes the base to flip over. So instead of 1/5, it's 5 over 1. And 5 over 1, well, hey, guess what? That's greater than 1. Therefore, that's exponential growth. And the ordered pair, well, what is that number that's in front? That number that's in front is a 1. So even though you don't see that starting value, that number in front, it is still a 1. Now here they have said something interesting. They said type an ordered pair. So we would need to type 0, 1 instead of just putting a 1. So just follow the instructions on Math Excel so you'll understand. Now, how do you handle changes? How do you find growth factors when you just say, hey, something's going up by 50%? One thing I have to encourage you to understand is that we always start with 100%. No matter how much we are given, whether it's $5 or 5,000 buffalo, it's always 100% of the starting amount. Okay, whatever that is. But in terms of percentages, it's always starting at 100%. I get kids all the time that think that we start with 0%. We do not start with 0%. We start with 100%. So, that being said, we would add 50% to that. Now, when we do that, that takes us up to 150%. Everything starts at 100%. It either goes up or it goes down. Obviously, in this case, it's going up because they said they were adding 50%. Now, what growth factor do you get out of that? Move the decimal point. Move the decimal point 2 places. 1.5. That's the growth factor. And remember how we said if it's greater than 1, it's growth. If it's less than 1, it's decay. Well, we can clearly see it's greater than 1. The growth factor is 1.5. Okay, let's look at the next example. Suppose we were losing 15%. You'll notice that I changed it. If we're losing 15%, we're going from 100% down 15% to 85%. Well, remember, move the decimal place over. That would give me 0.85. And remember how we talked about if that number is less than 1, then we're talking about decay. The decay factor is 0.85. Okay? So just keep in mind, if you start with that percentage, you add or subtract that percentage, and then convert it to a decimal. I really encourage you to do that every single time, because what if it's over? Let's say we have a question where it's over 100%. What if they're adding 200%? Okay, I get kids that in this situation, they just write down 2. They're like, move the decimal over 2 places. Well, they forget that you're starting with 100% and you're going up 200%. So you actually land at, yes, you guessed it, 300%. Therefore, the growth factor for this would be 3. So start with 100% and either subtract or add as you need to. And that's the end of Swyk number 1.